Hey, in this video we'll be talking a little bit further about the standard template library. So with the standard template library, we are given a bunch of data types, containers, and functions to work with that can make our job easier solving problems in our programming. So I'm in Visual Studio and I'm looking at the project that we had put together in a previous lesson. This one is showing off just some kind of basic features of the vector class. So to use the vector class, we included the vector header. This is the built-in standard template library version of vector. And a vector is a growable array. It's a container that can change size as you add things to it. So in this case, I added just 3 elements, so the vector had to grow in order to fit those contents. And then I was able to print it out, and I also showed a different way to print out, to access each of these elements. So the first way was using the same notation you would use for an array. This is using the square brackets, the subscript operator or array access indexing operator. So it works just like an array, and that's mostly because vector is usually implemented internally as an array that has to change size, so they might have to replace the array and to make a bigger one. But there's this other way that you can access the vector's elements. You can visit them one at a time using an iterator. So the way to write this out is somewhat verbose. It's a lot more typing than just using an index and controlling your loop using an index. But it does have some advantages, and I'll show you what those are with a different type. Instead of a vector, let's go and look at a list. So I have this different project, and to get access to a list, I need to include the list header, and then I can use the STL list type. A list of, let's say, integers, and then my list, and I can use some of the same functions. There's a push back function, there's a push front function, so we can access add things onto both ends of this container. So it is a linear container just like a vector, but the difference is how it's internally represented. Where a vector is more like an array where you can jump around between elements, a list is implemented as a linked list. You can think of it as a pointer that points to the first element. Here it's going to be, oh man, the ordering of this is going to mess me up. I pushed front 10, so 10 should be in front. So 10 should be the first thing that's linked. So imagine it as a pointer to the value 10. But then there's a pointer there that points on to the next value, 37. And if I added some more, like 99, 0, then I've got the sequence 10, 37, 99, 0. And you have a link, a pointer, that is connecting these in a sequence. And that means when you want to traverse this list, you can't just jump around, like say, what is the element in the middle of the list. You have to start at the beginning and go on toward the end in order to get to the middle. And that means you cannot use the square brackets notation. They don't implement the operator square brackets because it doesn't make sense for this container. And there are some containers where it makes even less sense. So for this one, you can still use the iterator pattern. So let's see, we have a list of integers, and in that type is the iterator type. and I get an iterator that starts at the beginning of my list, and I want to keep iterating as long as the iterator does not point off the end. Okay, and ++e will increment that iterator, move it on to the next element each time so that I can print it out. Just like before, and a lot like using pointers, we want to use the asterisk to dereference this this iterator. Let me just put spaces between them and then keep them all on one line as I print them out. Okay, let me run that. Okay, cool. So that's the order we expected. 10, 37, 99, 0. And so an iterator is starting at the beginning, and it is incrementing, going to the next element, next element, next element, until we get to the end. And we access each of those elements, the values stored there, by dereferencing that iterator. All right, so this is the way to move through and traverse a linked list. But there are other types that that this is really important for. Other types that are more complicated, and you just can't access them randomly, like jumping around in the container. You need to access them through an iterator. And the fact that this iterator interface exists for these containers means that you can treat them similarly. If you have an algorithm that works for one of these containers using iterators, it'll work for all of them. It'll work for them all the same way. So that's pretty handy, and that's part of why the standard template library exists, to be able to put these common structures together and functions that can work on all of those structures. All right, we'll talk more about those other structures in the next video. See ya.